Hi, it's Mr. Benson here. I've got the second lot of motion questions now. There are quite a few more, so I may split this into several videos, and there is a third lot coming as well just to finish them off. This is actually the second time I've tried to record this because my computer crashed earlier, which makes me super sad, but at least I know what I'm talking about the second time. So the first question we get, we've got a stack of blocks sitting on a table. Now we're asked about the force of block C on block B, and we have to explain our answers in terms of Newton's laws. Now that is a terrible arrow. This is meant to be a vertical arrow going upwards. So what we're being asked about here is the upwards force from C on B. Now the only thing that can be is a reaction force. So we can start thinking along those lines. Now what we know is that the reaction force has got to be reacting against something, so it's got to be reacting against the weight of A and B. Now the mass of A and B is 0.06 kilograms, so W equals mg, which is 0.06 times 10. So we've got a force of 0.6 newtons, and it is up. Probably worth stating the direction there. Although block C on block B, I guess it's kind of given in this as well. Okay, explain your answers in terms of Newton's laws. Well, third law, which is, now I'm just going to say it, I'm not going to write it. Every action has an equal and opposite reaction. So the block C reacts to the weight of A and B. So you're showing that you understand that the stationary block C will have a reaction force to the weight pushed down above it, from above I mean. Okay, moving on. The table is now removed and the block's free fall. Now this is an important point here. What does free fall mean? It means they're accelerating at 10 meters per second squared. Okay, what is the force by block B on block C? So this is saying what is the weight of block B on block C. Now basically in our explanation we need to be thinking about how W equals mg minus ma. Now they're both accelerating at A equals 10, so weight force is 0 newtons. So the force of B on C is 0 newtons, and it is because they are both in free fall, they're both accelerating at 10 meters per second, and so there is no reaction force and no apparent weight. Okay, a ride at a fun fair involves a car travelling around a vertical circle of radius 15 meters. So start to think about what we're being told. We've got R equals 15 meters. The arrow indicates the direction of travel. Now what is the minimum speed that the car can have at position A if it's not to leave the rails and start to fall? Now there's a couple of things they're telling you about here. So the minimum speed, so they're saying exactly the car is following the circular path and not starting to fall. So what that means is that how do I say this one? The acceleration of the car, the centripetal acceleration of the car, at that point is exactly 10 meters per second squared. Now, if it was different to that, then the car would either be starting to fall, or it would be being accelerated. No, sorry, it would actually effectively being pushed up on harder onto the track. So it would be exceeding that minimum speed. So anyway, we've got A equals 10 meters per second squared, and it's, you know, this is usually the question that you get asked, although you might get a more complicated apparent weight one. So again, what do we know? We know R equals 15 meters. We know A equals 10 meters per second squared. Now we're asked for velocity, and there's only one equation in circular motion that links all these things together, and you need to start getting familiar with these. We're trying to find V, so V is going to be the square root of AR, which is the square root of 15 times 10, and that is 12 meters per second squared. Melanie's got a mass of 60 kilos. She's a passenger in the car. What will her apparent weight be at position A when the car is travelling at this minimum speed? Explain your answer. So, 0 newtons. So you shouldn't spend any time on calculating that one. Effectively, at that point, Melanie's in free fall. She is, for a very short period of time, and she's at the very top of that circle, is falling straight down. It just happens that although she is falling straight down, while she's doing that, she's following that circular path. Actually, I've said that terribly badly. She's accelerating straight down, but she's following a circular path because she still has horizontal velocity as well. So she's got an acceleration of 10 meters per second squared. Now again, we can sort of think about W equals, so her apparent weight is mg minus ma. She's not experiencing any reaction force, as the car is effectively accelerating straight down at 10 meters per second squared at that moment as well. Okay, question 11. The car is now at the bottom of the circle. It's got a speed of approximately 5.5 meters per second squared, which, if you think about it, doesn't make any sense at all, because it's going a lot faster at the top than it is at the bottom in this example, which is rather silly, but that's okay. You don't need to worry about the silliness of questions, just follow the information. So we know V equals 5.5 meters per second. Now she's still being accelerated in circular motion, so we've got to think about her centripetal acceleration, which is still given by v squared over r. Now v squared, well, it's 5.5 squared, r is still 15, and so we've got 2 meters per second squared is her centripetal acceleration. Now apparent weight is mg minus ma. Now in this case, I'm going to add a minus sign on that centripetal acceleration up here, or maybe I shouldn't add it there, but you do need to put it into your calculations, because if you think about it, we've got mg is in this direction, but the acceleration is in the opposite direction, so one of them needs to be a negative sign. So we've got mg 60 times 10 minus 60 times minus 2. So we have got 720 newtons is her apparent weight at that point, which is slightly heavier than normal.